Okay, so first case study for us is going to be for MovieFlix. And what is MovieFlix? Well, it's a company that allows you to watch TV shows and movies on demand. And the business comes to you and they want the following capabilities. They want to make sure the user can resume the video where they left it off. They want to build a user profile in real time. They recommend the next show to the user in real time, store all the data in the analytics store. So my question to you is, how would you implement this using Kafka? Now I want you to pause this video and just take some time with a sheet of paper to figure out what you need. Producers, consumers, Kafka Connect, Kafka Streams, anything you think is useful, just put it on a sheet of paper. Take 5 minutes, then come back to this video, and then I'll show you the response. Okay, so I hope you've done it. Now let's get started. So we have Kafka in the middle, and first topic that I think should be interesting is show position. And so it basically is a topic that tells us how far the users have consumed a TV show, even within a video. So something needs to produce to that show position. So I'm thinking that there is a video player on people's browser and they're playing videos. And while the video is playing, once in a while, it will send some data to something that called the video position service. And it's kind of a proxy. And that thing is a producer and it will send the data it receives from the video players to Kafka to the show position. So the video position service most likely will have to do some work to make sure that the data it receives is correct before sending it to Kafka. Okay, so from that, well, to implement the resume capability, the resume service, well, we could have a resuming service, a consumer of that topic show position, which is going to have a database of how far basically each user for each show, how far they've been consuming. They don't need to know every consumption point, they just need to know the latest. So that's how I see my resuming service. And so basically when someone opens up their browser because they just stopped playing a video and they want to restart it 2 days later, then the video player does a request to the resuming service to say, hey, where was the last time I read the video? And the resuming service says, hey, this is it. And this is it. So that's for the resume and storing position. Now we need to think about recommendations. So we have data from the show position about which user watches which show and how far. So that's actually really good data because we know exactly which users, what they like as far as shows. And if they go all the way to the end of the season for the show, well, they must have liked it. If not, if they stop us for 5 minutes and never get back to it, they must have hated it. So I'm thinking there could be a recommendation engine in real time that is maybe powered by Kafka Streams that takes the show position, performs some really good algorithm on all these metrics, and then from there creates recommendations in real time. Now these recommendations are consumed by a recommendation service. And basically whenever I quit my video player and go back to this portal website of MovieFlix, well, the recommendation service is going to say, this TV show is the right one for you next. Just an idea, right? Finally, all this data is really good data and shouldn't stay in Kafka. So I'm thinking there should be an analytics consumer powered by maybe Kafka Connect to put this into an analytics store for further processing, such as Hadoop. And so even that analytics store can actually power our recommendation engine in real time. I haven't drawn the arrow, but you can think of this. So this is an interesting Kafka architecture. Now let's have some comments about it. For the show position topic, it's a topic that can definitely have multiple producers, okay? All around the world, people are going to watch my TV shows, and so multiple producers will put data into the topic. To me, it should be highly distributed because there's going to be high volume, there's going to be some data sent every 20, 30 seconds. So I would say at least 30 partitions, but again, I would need to measure it before saying such a number. Now, if I were to choose a key, I would choose user ID for that topic, and the reason I would choose the user ID key is that I probably want all the data from my users to be in order, okay? I don't really care about ordering across users, but I care about ordering for one user. So I would choose user ID as a partitioning key. Now for the recommendations topic, the Kafka Streams job, I'd say, may source data from the analytical store for historical training or to train the model once in a while. And to me, the recommendations topic is more of a low volume topic, right? There's not going to be as many recommendations. There's not going to be a new recommendation every 30 seconds. Definitely not. So if I were to choose a key, I would choose user ID as well. And partitions, I would choose definitely less partitions than the show position topic. So I hope that's helpful. I hope that gives you an idea of how solution architecture works on Kafka. And if you like this exercise, well, there's a couple more in the next lectures.